So this is going to be how to integrate using U substitution, which is going to be basically undoing the chain rule. You remember if you wanted to take the derivative of something like the sine of x cubed, you would have to do the chain rule, and that would be cosine of x cubed. The derivative of the outside shell is sine of something, so that would be cosine of that same something. And then the peanut, or the inside, would be x cubed, so the derivative of x cubed is 3x squared. Or in other words, 3x squared cosine x cubed. So if you wanted to do the integral of 3x squared cosine x cubed dx, you're going to have to undo the chain rule. And so the best thing is to think of this maybe in terms of which part is the derivative of the peanut and which part was the shell originally. So if you see that there are two parts, that there are a derivative of a peanut and a peanut, sometimes it's best to use this technique called U substitution. So it doesn't really matter if you're using a U, but let's say you use a U and you let U be the peanut, which is x cubed. Then the derivative of that would be 3x squared. And you'll notice this shows up perfectly right here. And so what I have here is the integral of cosine of U du. Let me run over why that is. This right here, this should have a dx, the derivative of x cubed, we're in terms of x's, so we'll put a dx here. But the du can be substituted for 3x squared dx, which is right here. And the cosine just comes down here, and we said that u was x cubed. So we have cosine of u. Here's what u is. U was the peanut, or the x cubed. And then this right here combined with this right here will give me du. So that's what I have right here. Cosine of u du. Now the integral of cosine u is pretty easy because the derivative of sine x is cosine x, so the integral of cosine x is sine x. So this would be sine of u plus c. And you'll never want to leave your answer with u's. If the original problem, this blue problem, had x's, we'll want to go ahead and put the x's back in. So remember, u was x cubed. So that's how you undo the chain rule. You have to establish what the peanut is and let u be that. Sometimes you'll pick the wrong thing and you'll say du is something that doesn't come up here, and then you'll realize that you picked the wrong u. But you put u here, so u is x cubed, then du is 3x squared, so that's where this 3x squared dx turned into a du, because that's what du is. And you just integrate as normal, put your x's back in if you want. So let me do another example of that. Okay, so we'll want to try to let u be the peanut, which is 3x plus 1. Let's start with that. Which means that the derivative of u is 3 dx. And that's almost what I have here. So if I bring a 1/2 out, remember you're allowed to bring out anything you want. Then I have exactly what I need. So what I've done is I thought of this as like 3 over 2. That's really like, let's bring this 1/2 out here, the 2 that's in the bottom. So I just rewrote this problem to get the du to match up a little bit better, because I need a 3 and a dx to be able to trade out for du. And my square root symbol is still there, but underneath there, 3x plus 1 is the same thing as u. And I can integrate the square root of u pretty easily. The square root of u, which is u to the 1/2. You integrate this, you add 1 to the power, which would be 3 halves, and you divide by 3 halves. Don't forget about this one that was still out here. We're going to bring that down, this 1/2. Okay. So, flip the bottom and multiply. So this would be 1/3 u to the 3 halves plus c would be your answer, but you don't want to leave it with u's. So you'll say 1/3. Remember, u was 3x plus 1 to the 3 halves plus c. And that's it. So, again, let me go over this again. I start out with saying that u is my peanut usually. That's what I'll start with saying. So then du was 3 dx. Well, I didn't have a 3 here. I had a 3 over 2, so I pulled out a 1 over 2, and it left me with a 3 there. See, this is like 3 times 1/2. I pulled out the 1/2, and then I still had the 3 here. Okay, so then I have 3 dx, that turns into du. And I have a square root symbol that stayed there, and my peanut turned into the u from the original premise that u was the peanut. Integrating square root of u's easily, that's easily done. U to the 3 halves over 3 halves, and then you just bring the 1/2 with it. So all I did at the end was put this back in terms of x's instead of u's. U is something we kind of made up to get this problem done, so you wouldn't want to say your answer in terms of u's. You'd want to put your answer back the way it started in terms of x's.